Okay, guys, go ahead and get out your page number 12. That's what we're going to do today. Again, make sure your name's at the top so that when you submit a picture, I can see your name at the top. Today, we're going to talk about nomenclature with ternary ionic compounds. Okay, so we already talked about binary ionic compounds, compounds that had 2 elements in it. Okay, ternary means it has 3 elements in it. So it's basically if you see more than 2. More than 2, than 2. Really, it means 3, but okay, if you have more than 2, but sometimes it can be more than 3 even. Okay, so ternary ionic compound. So let's look and see what these guys have in common. So calcium phosphate. Ooh, I see parentheses sometimes. Sometimes I don't see parentheses. See, this one has more than 3 elements. This one has 4 different elements. So we have a few different things going on here, but all of these have more than 2 elements in them, right? And that's how we know that it's a ternary ionic compound. And you might notice that the ending does not always end in "ide." Sometimes it does, but not always. Sometimes it ends in "ate." Sometimes it ends in "ide." Sometimes it ends in "ate." So the key here is if you see more than 2 capital letters, that means that there are more than 2 elements, which means that there is a polyatomic ion in there somewhere, okay? Wow, it's like really hard to see my highlighter, but it is highlighted, so you should be highlighting it too. Okay, so let's practice. So let's look at this first example here. I see more than 2 elements because I see more than 2 capital letters. I see 3 different elements. So that means that I have a polyatomic ion in there somewhere. Your polyatomic ions, you learned about this last year, but if you forgot, flip your paper over. These are the polyatomic ions that you need to know for 8th grade chemistry. Okay, these are the ones you need to know for 8th grade chemistry. These are the ones that you should memorize. Make some flashcards, memorize these. Okay, there are 1, 2, I think there's 11 of them. And these guys are so important. There's 11 of them. Okay, you need to know these like the back of your hand. Okay, and again, guys, I don't know what the end of the year is going to look like, but if they bring you back to school to take pre-comps and you don't have your notes in front of you, then you're going to have these memorized. So I would suggest that you make some flashcards and get these down in your brain, okay? There's a lot more than just these 11 polyatomic ions that exist, though. Here's a more extensive list just for reference, okay? These are just for reference, okay? So if one of these shows up, you can reference this to use it, but don't expect you to memorize these, okay? Now, what does polyatomic ion mean? Poly means many atoms. Okay, so it's an ion, so something with a charge, positive or negative charge, and it has many atoms in it. Okay, so all of these are polyatomic ions. Okay, they have more than 1 atom in it, and they have a charge. Okay, so this first one, I see NaNO3. So write the name of the first element, unless it's ammonium, and what do you notice that's different about ammonium? Ammonium is our positively charged polyatomic ion. This is the only one that has a positive charge. Okay, the rest of them are negative charges. So if you don't see NH4, then there's no ammonium in it. So we're going to name our first element, which is sodium. And then we'll name our polyatomic ion. Write the name of the polyatomic ion. Don't change the ending. So this is NO3. So we need to find a polyatomic ion that has NO3 in it. Let's see, NO3. Where is it? Right here. Nitrate. Notice it ends in 8. We don't change the ending, we just leave it as nitrate, okay? So this is called sodium nitrate. Done. Awesome. Okay. I'm going to turn this off. Maybe a little bit easier to see. Okay, the next one, I have magnesium. And then I have OH, and there's a 2 next to it. Let's see if that's significant. Okay, so if it is an OH, we find the one that has OH, and I see it right here. It's hydroxide. There's no 2 there, but that's okay. Because if you guys think about it, where does this 2 come from? The 2 comes from the fact that the charge on the magnesium was originally a +2, and it was crisscrossed over. Okay, so that's where the charge comes. That's where the 2 comes from. So we don't need to worry about it. We don't need to do anything with it in our name, because magnesium is not a transition metal, so we just leave magnesium hydroxide, done. Okay, next one. I've got Cu. Cu is copper. Okay, so we always need to ask ourselves when we come across a metal, is this a transition metal or not? Okay, well, copper is right here on our periodic table, okay? That's a transition metal. We don't know its charge. So that means we're going to need a Roman numeral. So we're going to have copper something, and then we need to find out the name of this polyatomic ion here, ClO3. ClO3 is right here. It's a chlorate, okay, chlorate. So it's going to be copper something chlorate. So we need to figure out what the charge is on this copper here. Well, the chlorate, ClO3, it said right here that chlorate has a -1 charge, just a negative. So it's a -1 charge. So its charge is -1. Okay, and there's 2 of these, right? Because there's a 2 here. So we know we have 2 of these chlorates. And we have 1 of these coppers. So what does the charge on the copper have to be? If you have 2 of these and each of them is a -1, that's a total of -2. So to cancel that out, this one would have to be a +2. So it's going to be copper 2 chlorate. Okay? Okie dokie. This last one here. This first element is not a metal. It's nitrogen. Okay? This means that instead of there being a metal that's coming first, we're going to have ammonium come first. Because remember, what the positive thing always comes first. So ammonium is NH4+. Okay, so the first thing we have here, instead of naming a metal, we're going to say ammonium. Ammonium. And then, what do we have left over? We only have 1 element left over. So it's not a polyatomic ion, it's just chlorine. So in that case, if you just have 1 element left over, and this will only happen when you're dealing with ammonium, because ammoniums are only positively charged polyatomic ion, then we just say chloride. Okay, because it's just a single element, it's not a polyatomic ion. Okay, so ammonium chloride. All right, go ahead and pause the video and do the U-tries by yourself. All right, guys, go ahead and check your answers here. See how you did? Okay, let's move on. Now, what if you need to do it the other way around? Okay, what if you're given a name and you need to write a formula? Okay, so for what it says right here, it says write out the symbol for the single element and the full formula for the polyatomic ion. And then it says put the polyatomic ion in parentheses, and then you've got to swap and drop the charges. If the parentheses were unnecessary, you can erase them. So let's take a look at this. We've got calcium. So calcium is Ca, and we've got phosphate. I know this is a polyatomic ion because it ends in 8. If it ends in 8, it's a dead giveaway. Hey, this is a polyatomic ion. Go look it up on your polyatomic ion list. So phosphate is right here. It's PO4 with a 3- charge. PO4 with a 3- or -3. And calcium, if we look up on our periodic table, has a charge of, oh, I don't have it written here, but that's +2. That's +2 because it's in group 2. Okay, so now I'm going to, it says put the polyatomic ion in parentheses, like this. And then swap and drop. So it'll be Ca3PO4 2. And the reason we have to put parentheses here is because this, if we just put it at the 2 here without parentheses, that would look like a 42. That's crazy. So you need to put it in parentheses because it's telling you have 2 of these phosphate things, okay? Okay, let's try another one. So iron 3 nitrate. So iron is Fe. It's a transition metal. You know it's transition metal because it tells you the charge right there. So you don't even have to look it up because there's nothing to look up. You just go with whatever this says. This is a +3. Then nitrate. You know this is a polyatomic ion because it ends in 8. So let's look up nitrate on our list. Nitrate is NO3-. NO3- or -1, same thing. Okay, so let's put our polyatomic ion in parentheses and then let's swap and drop our charges. So it's going to be Fe. Do I need to write the 1? No, I don't need to write the 1 for a subscript. And then NO3, and then the 3 gets crisscrossed over. Okay? All right. Okie doke, the last one here, barium hydroxide. Barium hydroxide. So barium, you have to look up its charge on the periodic table. It's +2. And then hydroxide, this ends in "ide", but it's a polyatomic ion. Hydroxide and cyanide are both polyatomic ions that end in "ide," not in "ate" or "ite." Okay, and there's also like peroxide. I think those might be the only ones on this list. Okay, so just keep on a lookout for hydroxide and cyanide, and then you won't see peroxide super often, but these ones do end in "ide." Okay, so hydroxide is OH with a -1 charge. Now, you need to put parentheses around hydroxide. Oops. Super often, kids forget that they need to put parentheses around hydroxide because it doesn't already have a subscript on it. So don't forget to put your parentheses around hydroxide. So we're going to go BaOH2. You have to put your parentheses around the hydroxide before you crisscross that 2 over, okay? All right, go ahead and pause the video and then try the U-tries. All right, guys, go ahead and check your answers. All right. Good job, guys. Go ahead and work on the assignment.